Hello, good morning, friends. Let's continue our journey. We started with fundamentals on understanding the agentic AI. We understood what is retrieval augmented generation and how to do chunking, vector embedding. So, let's understand context management. Retrieval augmented generation is just one form of providing the context, and then we provide context based on the recent chat history, a user profile, and so on, right? So consider an example where it's something where a person is driving and needs a solution, provides a real time information based on where the location and the climate and how whether the person should drive or stop, or the health of the person, and also one of the parameter to consider in such solution. Or if it's something related to stock market where the information is continuously changing and in real time, we need to process the context is in real time. Also, suppose someone is trying to understand or the what Jaguar is. So where the based on where you are and what location you are, the meaning of the word Jaguar will change, whether it's an animal or it's a car or it's a guitar. So like you are at you are on a road and driving and you discuss Jaguar, or you are in a live concert and you discuss Jaguar, or uh, you are in a like a sanctuary or a park and you discuss Jaguar. So the context changes the meaning. So and accordingly, so in what context the person is saying, it matters, right? And when we implement such solutions, the other context is there's a long conversation and the history, right? And that also provides the context, but there is a limitation to the system or the tokens which a solution or a language model can take in a one go is having its own limitation. So how to do the summarization, and that needs to be considered, right? So suppose a system can take only 4,000 tokens, and while the year history is of 50,000 words, how you will reduce it to 4,000 tokens and still preserve the essence of it, right? Now the context also provides in the real time. It's a Google map, or your GPS location, longitude, latitude, the weather where you are driving at present. And this context will matter in like suppose there is a truck company which has fleet of vehicles driving and needs to make sure the safety of driver and the vehicles and the goods they are carrying. So in real time they should be able to know the direction which they are driving 50 miles ahead, where there will be a hailstorm or a thunderstorm, or there is a like in some states there is snow, some states it's dry. So in they need to change the tires for the and different road conditions. So all such parameters, context in the real time is important. Similarly, someone is investing in a stock intraday, interday, and a agentic solution needs to provide the inputs. So in real time, the information should be able to be processed and saved in the knowledge base, and based on the user question, it should be able to retrieve and respond. Now the other thing is, like, now with so many different data sources, which data source how much weightage needs to be given. So graph neural networks are implemented, and it has the relation among the different data sources, and accordingly gives the weightage to it for inferencing and provides the response to the user. right? And then we need to have the domain specific knowledge. Suppose it's a solution specific to healthcare, so all the ontology graph of the healthcare or the legal ontology graph is referenced by putting into the vector embeddings, right? And then the sliding window, the context changes with time, and then accordingly the right context should be taken into consideration, further giving the response of the immediate query or the event, right? For that the perplexity score should be measured and compared whether how much the response is surprising or it's in line. And so to do it in the real time scenarios, how the user has behaved, set of people have behaved, and how agentic solution is responding to the similar situations and inputs, and accordingly the system, the comparison and the matrix can be created to evaluate. So context is provided in different forms. That is, one is retrieval augmented generation, where you provide the FAQs knowledge base in the form of vector embeddings, and then different sources of input create the graphical neural network among it to give the right weightage to the different inputs coming in. And then the third is the transformers model we use, so the long histories are made shorter and without losing the context and the essence, right? So the context engine is about semantic processing core, human interaction, multimodal fusion engine, temporal integration, knowledge graph interface, and decision logic module. And the different inputs which are taken are the data streams, the different size of data, velocity, variety, and the volume in which it comes in needs to be handled. The environmental sensors, which are continuously giving us the real-time data, which can be fed into using queue services, and different like in queues, there will be a broadcaster and there will be a consumer, so different agents will consume different information coming in on the queue. And the third is the user interaction with the solution, so human feedback and human intervention. And the output the context will give is the in the different forms, and decision execution engine will give the actionable insights, and integration hub will optimize the workflows. So if there is only a language model to which a user asks any query and it gives a response, is like in a school days when you go for an exam and some descriptive question is there. Even if you don't know answer, you write few lines guessing that you may get some marks, so you try to hallucinate. So similarly, language models are trained on data under specific time and temporal, so based on that it gives the response, so it does not have the real-time information. So in case of context aware model, how the context is built, the user asks any question, or it could be an event which is triggering the action to be taken. Along with that, we have the user history. It could be its profile, medical history, and different, and the location where the at present the person is, and the domain knowledge. Okay, so the domain knowledge comes in the form of ontology graphs or so the six strategies for providing the context is knowledge base, that is retrieval augmented generation, long history, so long there's how to preserve the history, how to keep the essence and make it short, user profiling, collect social information, user behavior, and so on, based on what kind of solution we are building, right? Whether it's a online merchant selling products and recommendation, or it could be a healthcare solution about a person. And then the multi-source collection in real time, based on the sensors and the APIs to get the input from those sensors. Then the weather and the environmental and real-time weather, location, demographic information, domain-specific context, in the form of ontology for healthcare or legal or any domain for which the solution is built. Okay. So the different inputs which goes in are the user behavior, and the time and the temporal in real time, the sensors giving the input, and the domain knowledge, FAQs. So the context is long-term static information, real-time information, and user behavior interaction to it. So all these inputs are first different forms which are coming. How the weightage should be given to each of them is taken care by graph neural networks, GNN. And then comes the attention mechanism. So how the attention and the weightage should be given to each of them. And then summarizing the history of it. So for attention mechanism, consider like you are in a example in a party where we are dancing. There is a loud music, but suddenly someone says fire. So here the brain attention gives more weightage to it, and then you find a way to escape from the place. So similarly, in these solutions, when the different inputs are context are there, which context should be given more weightage, so accordingly GNN will help on it. So memory flow is a challenge. It's a limitation even for the embedding models and the agents or the language models has a token limitation. So how to over the period of time the memory grows, the chat history grows. So it can be reduced with the help of sliding mechanism, and based on the temporal, how old is the history, how much compression needs to be done. And it can be done with the transformer library which was developed by Google. So the entire chat history can be given as an input, and it request for the summarization of it. The next important thing is user profiling and personalization to provide the context. So like if we use some online shopping, you will see the recommendations. Whether you use YouTube to watch videos, you will see the recommendations, or if watch any Netflix kind of channels where you watch some music or movies, and you see the recommendations. So how it is done, and in an optimized way. So like there are millions of users and millions of songs or movies, and you cannot save such a sparse matrix of m into n unique in dimensions. So it can be done by doing the matrix factorization, where you group the people like similar nature or similar behavior. So the number of users decreases, and the number of movies or song decreases. So the smaller matrix can be created, and accordingly recommendation can be done for that pool of users or the clusters, right? So for doing such uh, recommendations, what we can the way it can be done is like with users information, embedding is created, and all the items with their attributes, the embedding is created, and then we find which user is close to which songs or movies, or what people are close to watching this kind of movies or songs, and that reference is used for recommendation. Now in the real time, when we collect different information about the weather, location, the sensors giving the input, it should not be stale and real time to give the using that context, give the right recommendation to the user. So in such case, the queues can be used where the information is broadcasted and the right agent consumes it based on the action which it needs to, the role which it is playing. Right, so like instead of saying it is raining, you should be able to say it is raining, I need to take an umbrella, or the weather is good, there is a park nearby and you can enjoy the weather. Yeah. If this how it can be done is it extracts the current your location, longitude, latitude, and based on the weather, it finds whether at this location there is a rain and you are not at home. Probably there is a restaurant nearby where you can have a coffee, or if it's not raining, there's a park nearby where you can enjoy the weather. So what kind of challenges when we face when we handle such kind of heterogeneous solutions where different inputs will come in different form and size, and that needs to be stored, processed, and made into a common form which can be understood by the system. Then while the input is coming, it may have noise, it may have inconsistent data. So for that, data processing, data cleaning is required, whether it's a AI or a data or a big data solution. So still the data processing concepts and the modules are the same. And then at the same time, the scalability should be handled and taken care of based on the volume, variety, and the three V's of the data, right? So the different sources the data comes from, and which source has to be given weightage at based on the location and of the user and the solution. It can be done by using graph neural networks and attention mechanism. Like suppose you are driving a car and you are listening to a sad song, and user input is like, it says like I have pain in a chest, and the historical information says that a person has a medical condition. So there are 4 different nodes giving these 4 different inputs, and now an agent needs to give a solution or the alert the user. So how for all the different nodes, which node it should give how much weightage, such things can be taken care by graphical neural networks, right? And for the transparency, this weightage given to all the different nodes and the inputs should be shared with the user, right? Now, one of the important pillars is the domain knowledge. So, how the domain knowledge can be uh, uh, utilized in the agentic solution is like uh, based on what domain solution is, whether it's a healthcare or a legacy. Those ontology graphs can be imported into vector embeddings, and it can be utilized to for decision making, right? So suppose when we say flu and fever in the language models based on correlation, it will understand that flu and fever comes together, and in their cosine similarity distance will be less. But in case of domain knowledge or the ontology graph, very same thing is based on the ontology graph, and mentioned to the so retrieved from by the agentic solution. So it is more of deterministic and not probabilistic. So what are the operational practices which we discussed, and to implement provide context is like window management. So based on the history, the context is changed, and so accordingly we summarize it. The other thing is we use different models to provide the input. It could be text, image, audio. So like if the person is at like we discussed the earlier example of it's a rainy day, so the any image or the video or the audio input can be taken as well the context. So like even while the person is driving, and what kind of song he's listening, it's a sad song, defines the mood of the person. And governance is like when we give the weightage to different nodes which are providing the input, and the helps in decision making. So how much weightage is given to those different nodes providing the context is revealed with the user. Now to evaluate whether the solution is giving a surprise responses, or it's deterministic, so the perplexity can be calculated and compared, and if the perplexity is low, means the solution is working as expected, and accuracy has to be high, right? So for the evaluation and revealing the context score, we can utilize the embeddings, and here is the sample on how it can be implemented. So in short, this is how context management can be done. The inputs are the user history, real-time signals, domain knowledge. All this data is ingested. Some data is stored in the knowledge base, some comes live, and using queue it is consumed by the different agents, and then the weightage is done, given to the different inputs coming in, and the context is aligned dynamically, and it should take into consideration different multimodal inputs in the form of videos, audios about the location, and in the similar climatic conditions or the weather conditions, and accordingly decision is done, and the personalized response is given to the user based on its demography and age. It should be able to provide proactive recommendations, whether to drive ahead, there is a sandstorm coming in, to stop at the nearby hotel and take a break, and so on, right? So let's now see how much we have understood and by solving the quiz. So I'll read the questions, I'll show the options available and the hint, and then you can pause and evaluate yourself. First question: when integrating data from multiple sensors and APIs, which challenge involves reconciling different data formats and structures? Here are the options, and here is the hint. Next question: in the context of graph neural networks for data fusion, what is the primary role of the network layers? Here are the options, and here is the hint. Next question: which technique for managing long conversation histories involves using NLP models like T5 to condense the interaction text? Here are the options, and here is the hint. Next question: what is the primary function of retrieval augmented generation in context management? Here are the options, and here is the hint. Next question: in user profiling, which technique relies on identifying patterns in behavior to provide recommendations? Here are the options, and here is the hint. Next question: which architecture is specifically mentioned as a way to implement real-time context management using streaming data? Here are the options, and here is the hint. Which metric is used to measure the effectiveness of context-aware language models by evaluating how well they predict a sample? Here are the options, and here is the hint. Next question: when building an AI for a specialized field like law or medicine, why are ontologies and knowledge graph used? Here is the options, and here is the hint. What is the benefit of integrating multimodal context in an AI application? Here are the options, and here is the hint. Which best practice helps an AI manage context when the relevance of information changes over time as the session progresses? Here are the options, and here is the hint. So let's revise in short what we learned. So the different pillars of providing the context are the retrieval augmented generation, the user profile, the domain knowledge, then preserving the history without losing the essence. So we do the summarization, and then using ontology to provide the domain knowledge, and in real time how to do the weightage with the help of graphical neural networks with the different data sources, different nodes giving the input, and finally evaluating by doing the score comparison for perplexity and accuracy. Thank you for patient hearing. Do give your feedback and comments.